Hey there guys, Mr. Carlson here. Let's take a look at this problem where we have enthalpy and we're going to use stoichiometry to figure out some enthalpy changes. So we have this chemical reaction right here. We've got CH4 plus O2 to give us CO2 and water. And then over here to the side, they list this delta H, this enthalpy value, and it says negative 891 kilojoules per mole. So in other words, when this reaction happens, for every mole of methane that's burned, which is what's being explained right here, for every 1 mole of methane that's burned, there's this many kilojoules of energy that are released. Now we can use the stoichiometry of the equation to figure some different things out. So not only can we think about it in terms of methane, we could think about it in terms of the oxygen or the CO2 or the water. So for example, this first question says, what is the enthalpy change if 5.8 grams of methane is burned? Okay, so we can treat this question just like any other stoichiometry question where you have to convert from like grams of one thing to grams of another, or moles of one thing to moles of another. It's going to be just like that. So we can use this value here as a way to convert between energy and amount of something. Because if you look, it's kilojoules per mole of the substance. So for example, like with methane here, I could set it up as a conversion factor, like for every 1 mole of methane, there are 891 kilojoules of energy released, right? 891 kilojoules per 1 mole of methane. Or we could think about it with like O2. For every 2 moles of O2, there's 891 kilojoules of energy released. 2 because I've got a 2 in front of this, right? For every 2 moles of oxygen that are used up, there's this much, there's this much energy that's released. Remember that negative there is just referring to whether it's endo or exothermic, so it's negative because this is an exothermic reaction. That's the amount of energy that's going to be released. So to calculate this, if I want to know how much energy would be released if 5.8 grams of methane burns, well, I'm going to start with 5.8 grams of CH4, and then I'm just going to convert it from grams to kilojoules of energy, okay? So I'm going to go first, I'm going to get from grams to moles. And we know how to do that. We just got to get the molar mass for CH4, which is 16 grams. So 16 grams of CH4 for every 1 mole of CH4. And then we can go another step, because now I have this right here. I know how to convert from moles to kilojoules using this now. So I can just say that for every 1 mole of CH4, there are 891 kilojoules of energy that are released. And so if we look at this, this is a beautiful thing. Grams is going to cancel out, moles is going to cancel out in this step, and it would leave me with how many kilojoules of energy, or in other words, the enthalpy change. It's just another way of saying how much energy is going to be released. And so 5.8, I got to get my calculator here. Hold on a second. 5.8 divided by 16 times negative 891, and I get negative 320. I'm going to round. It says 322.98. I'll round it to 323 kilojoules of energy. So this would be the enthalpy change, or in other words, the amount of energy released if this amount of methane is burned. Let's take a look at another one. How much heat is evolved when 15 grams of CO2 are produced? So you should take a second, try and do this one before I do, and see if you get the right answer. Well, we'd start with the same thing. We're going to start with 15 grams of CO2. And we're going to do the same exact process we did right here, except for this time we have CO2 instead of CH4. So I'm going to use the molar mass for CO2 to get to moles of CO2 first. And the molar mass of CO2 is 44 grams per mole. CO2. And then we would use the same thing for energy. So this reaction, I can see that for every 1 mole of CO2 that's produced, there's this much energy. So I'm going to use that as my conversion factor. For every 1 mole of CO2, there are 891 kilojoules of energy released. And again, once again, grams goes away, moles is going to go away in this step, left with kilojoules. So this one, 15 divided by 44 times negative 891, and I get 304, we'll say, rounding it, kilojoules. Last one, just for fun, not because we have to, but because it's so much fun. How much heat is evolved if 15 grams of O2 reacts? So 15 grams O2, and we're going to convert that to moles. The molar mass of O2 is 32 grams per mole of O2. And now for the one thing with this, though, in the balanced equation there, we have 2 moles of O2 that are being used up for every negative 891. So I just want to make sure I plug that in. 2 moles of O2 for every 891 kilojoules of energy. And when we do the math on this, let's see, 15 divided by 32 times negative 891 divided by 2, and I get negative 209 kilojoules.